Well, depending on which clock we're looking at, this one says 8:28, that one says 8:30, so I think we are ready to go ahead and start. I can't figure out what time it is around here. So I welcome you Knights to this early morning. I think it's an appropriate title that we have for a first early morning talk, Alive with Activity. My name is Craig Brockschmidt, part of our Windows ecosystem team and the Windows team. I've been working with app building and working with our partners for the last couple of years, getting apps ready for the Windows Store and for the launch of Windows 8. We'll be talking in this session about live tiles notifications and the background tasks that are associated with those. My emphasis here is going to be on the service side of things, not so much on the client side, because we have really well put together samples on that, and we'll kind of review the API but not really spend much time looking at that code because we want to look at the server side of the code. We'll start by just getting a quick visual tour of the kinds of activity that we're trying to have in the system with live tiles and notifications and a few other things. Then look at the three ways that apps issue these updates, the role of background tasks, as I mentioned, and most importantly, writing and debugging the services that you use for things like periodic updates and push notifications. The whole purpose behind things like live tiles and toast notifications and what we're talking about here is this. How do we create a system that's alive with activity, or as one writer put it, a house built out of internet with all these little connections going out to all these different sources of information? But how do we do that without having to have apps run all the time? This is a really important consideration because if you're trying to optimize for battery life, which we're doing in a mobile environment, we don't want to have all this activity come at the cost of app code just running and running and running all the time. Because we can make a very alive system by just letting apps run all the time, but we're going to get 1 to 2 hours of battery life out of that. So a lot of what we're going to be seeing is how we do this without having those apps actually have to be running. So let's just take a quick visual tour and switch over to my demo machine here and go to the start screen that you've all known, you've seen and loved. And you can see as soon as I switch to that, you're seeing some tile updates happening. You can see various things going on. There's some secondary tiles here. If you look at, I don't think this mouse works, but like I got 4 people here: my wife, Charles Petzel, Douglas Purdy, and Don Box, many names that you might recognize, friends of mine on Facebook. And you can see that, like, one of Charles's last little blog posts, or one of his last Facebook posts about dealing with Hurricane Sandy in New York City is coming up. So we have, this is the basic place where we have the aliveness. And I'll be going over, I have another slide we can go over the exact specific little details of what each of these little pieces means that we see here. The next thing we want to see is toast notifications. Let me switch over to that sample here. Toast notification, let me say hello build and issue this for about, I'm going to do it 30 seconds out. We'll see this in a little while. And in the meantime, start the store and go and install an app, top free. Kyle's sitting here, so I'm going to install Kindle. He's one of my teammates here giving me support. So. And it's off and installing. You can see, there's an update happened. And you'll see that this toast notification stays up even though I'm in an app. I go between apps. I go to the start screen. There's that notification. And within a few seconds, we should also see the notification that I scheduled in another app that is actually now in the background and suspended, and yet its scheduled notification shows up. So we can have up to 3 of those show up at any given time on the start screen, on top of apps, on top of the desktop, and if they are issued from a lock screen capable app, they also show up on the lock screen. And then the other thing we want to see, just as a quick visual tour, is go to PC settings and realize that there's some things that the user can do to control what's going on here. If you go to PC settings notifications, you will see that a user can control how notifications appear around the system, whether they can play sounds, and in fact can also control notifications for every single app that has enabled them. Let me just quickly show, by the way, in the manifest, see this little thing right here? It says toast capable. I think that's big enough for everyone to see. If you have this set to no, you cannot issue toast notifications that show up. If you have it set to yes, then you can, and that manifest setting is what lists your app here in the notifications section of PC settings. So there's a little tie into that you want to know about. And then also the lock screen is another place where aliveness shows up. So this is my lock screen. There's not too much exciting stuff going on. I got one little email here, which is a badge logo plus a number, a badge update. And then one of the apps I have can issue the its latest tile update text will also show on the lock screen. Let me go show you where that comes from. Log back in. So here in PC settings on lock screen, see that I can set my image, but right down here is where the user sets which apps get to put badge updates on the lock screen. So I have the messaging app, mail, calendar, this is AccuWeather, this is the built-in weather app, and this is the background and raw notification samples from the SDK. And one of those can be set to show its little piece of text. So if I change that to be, let's set it to be the weather app, and I lock my screen, you'll see that instead of having something from my calendar show up, now I have the latest text update that would otherwise that went to my tile. Let me show you where that is also on the start screen. Somewhere right here. It's this tile on the weather app. That's the text that showed up on that part of the lock screen. So that's really what we have, kind of the three areas that you see this aliveness. You see the start screen, you see toast notifications, and you have the lock screen. So let's talk a little bit more details about some of these things. If we go to live tiles, the live tiles are defined by, the way they're structured is by predefined templates that end up being a piece of XML that you populate, and that XML payload is what then generates the update. The reason why we have predefined templates, or maybe one of the reasons, I can't say the reason, but if you think about the difference between a static start screen like we've known, and that's all over the place where it's just a page with a bunch of icons, not very interesting, not very alive, not very informative. The next stage above that is you can just say, well, okay, what the heck? Let everybody put whatever they want to on their icons or their tiles or whatever. I want to put video on it. I want to put interactive controls. I want to have all this motion. If you went to a start screen with that, it would be utter chaos eventually. And you wouldn't really want to go visit that start screen, would you? So by limiting what you can actually do on the start screen, and there's 40 some odd templates you can use for tiles. There's some templates you can use for toasts. By putting that limit on there and having the system control the animations that are happening, you get a much more unified view that's much cleaner and informative and doesn't cause epileptic seizures and things with people that are looking at all this jarring information. It's actually bringing it together in a way that makes really good sense. So as you know, on the start screen, you can have tiles that are square and wide. You can have text, you can have images, you can have a combination of both. And by the way, if you see something like the stock app that seems to do some interesting stuff and have things that don't quite fit the template, it's because it's just creating an image and putting that whole image on the tile. So you can put anything you want in an image dynamically and have a little bit more flexibility that way. You do want to be aware, though, that any image you create, any image that you reference for a tile as well as a toast notification, you have to be under 200K and under 1024 pixels in any one dimension. I'll mention this very much for photographs. It actually becomes a consideration because if you are trying to deal with scaling resolutions between 100, 140%, and 180%, a photograph at a 180% size for a wide tile, if you save it as a PNG, actually will typically go over 200K. You want to save those as JPEGs, and you'll actually get a better compression that comes down. So you'll want to be a little bit careful about that. I will mention also this idea of a peak animation, which you may have kind of noticed when a tile shows a picture and then shows text and then goes back to the picture. It actually goes up and down that way. That's a tile template that's actually like got two pieces of information, and the system's just going between the two. So you get lots of interesting effects that way. And then as we'll see, you can do updates. These are the three kinds of updates that we'll be talking about is local updates that can also be scheduled and also have expirations, periodic updates from a service, and push notifications. So on this slide, here's just a good rundown of a lot of the different templates that you see. Here's like a full image. Here's an image that has some sub-images in it. This is actually defined by 4 different images that you're sending to the tile. This is image with text and then just different text things. You'll see sometimes there's a badge logo on here. Sometimes there's the name of the app. This is something you control. Badges show up over here like this 12, this pause sign, this little glyph of a stop. All of these are called badges. Badges are managed separately from the rest of the tile, as we will see in a moment. And then you'll see as some of these animations happen, that's the kind of effect that we get going between. And this is simulating what a peak one looks like, where it, if I can go back here, you'll see that it peaks up, and if I animated it back, which this slide doesn't do, you would see the picture come back down again. Seeing toasts, they're similar but simpler. There's fewer toast templates because toasts by definition are simpler. Again, you see the little logos that come from the app, and let me actually switch over and make sure you know where that's coming from. In Visual Studio here, this little thing, badge logo, that particular field, this is what defines that little piece of the badge logo, as well as the logo that would appear on the lock screen if you were a lock screen capable app. This has to be a monochrome bitmap because as you can see on here, it really morphs it against the background color. So toasts can have images, they don't need to have images, but that's kind of where we're looking at there. And then just to review the lock screen, your badges and badge updates, badge logos and your badges show up along the bottom of the screen if you're lock screen capable. And again, the most recent tile text that comes from the one lock screen app that you've given that privilege to shows up there next to the clock. Okay. So here's how we want to think about updating. We want to figure out ways to get this activity happening in the system without having to have apps running all the time. Again, to keep battery life under control and to also keep us app programmers under control who would otherwise just like to run code all of the time. So there's 3 different ways you can do this. So any given update, which is the first item up here, is that an app can issue just direct updates whenever it wants to, if it's running. And it can schedule these out into the future. It can schedule them out in the future and at an expiration date, so you can define a window of time in which that update should appear and then disappear. And you can also enable what is called the notification queue, so that up to 5 different updates that you can individually tag will cycle through on that particular tile. Now the next step you can do with this is do what's called periodic updates. And this is where you give Windows 1 to 5 URIs that identify a service that go out, and that service will return the XML payload that defines a tile update or a badge update as you need it to. And so when the app is running, you set this up, and then the app can shut down, the app can be suspended, it doesn't really matter, and those updates will continue to happen. This is something we added after last year's build conference because everyone was asking, where can I get a background task to do this kind of periodic updating? They wanted some kind of thing on a timer, and we said, well, that's kind of a waste of time to do a background test for that. So we added this API in response to your feedback last year. And then, as you know, we have push notifications, which what you do in that is the app will set up its, the app will start get a channel URI, it's called, send it to its own service, and that service, when it knows it needs to send a notification, will trigger WNS, the Windows Push Notification Service, to send that down to that channel URI to that particular user's device in that particular app. So all of this is stuff that you can issue, that you can generate from a running app, and it's also things that you do from background tasks. So background tasks are often monitoring app state and different things going on, and so they can then issue tile and toast notifications and other updates, and even handle push notifications directly. The next thing I want to spend some time on is really understanding what's in an update. I'm not going to spend too much time on how we actually use the APIs to issue these things because there's great samples for that. But if you go to, first of all, these links that I have at the top, and you can get the slide decks later to see these, or just search on these names on the Dev Center. There are 4 different catalogs that show you, here's the tile templates you can use, here's the badges, here's the toasts you can use, here's the audio notifications you can use for the different toasts that come up. So you'll see all the options there and the basic XML for these. But there's more to the XML, as we'll see in a moment. I'm going to actually look at the schemas for those so we can see the full extent of their capabilities. So whenever you issue an update, whether it's your service or whether it's the app, the job is basically to build a piece of XML with references to whatever images you want, and then send that to the appropriate tile. And you can use references that go to the web, you can use them in your package, you can use them in your app data. All those URIs work just fine. I do want to also mention, if you look in the samples, you'll see this thing called the Notifications Extensions Library. It's a C# library that basically gives you an object model on top of this XML and makes it really easy to build them. And makes it easy to build them correctly, because if you are trying to build these things from scratch and you make a mistake, that update just never shows up and you don't see an error about it. Especially if you have it being issued from a service somewhere that you issue this piece of XML and it has a little mistake in it and you're wondering forever why it doesn't show up. So that's why this library was created, and it really helps reduce those mistakes. So let's start with the badge XML schema. This is the simplest one, the easiest one to play with and kind of work through the details. If you're trying to write your own service or trying to write updates, this is the one that's the most forgiving because it's got the least amount of information in it. Basically, it's got one element, a badge. It has a value, either a number from 1 to 99 or a number of text strings that identify specific glyphs. So you can't define your own glyph. There's about 20 different glyphs you can use. And then you can put a version number on it. That's it, very plain and simple. Now we look at the tile schema, on the other hand, has much more richness to it. A tile is a tile element, as you can see. It contains then a visual element, and the visual element can contain one or more binding elements. And let me explain how those work. So an update can actually include both square and wide tiles within one payload, and typically when you issue a tile update you want to include both because the user can switch between tile sizes at any time they want. So if you only issued a wide tile update and they're on the square tile, nothing shows up. If you're only issued a square tile update and the user is on a wide tile, nothing shows up. So you want to issue both at the same time. Any one of those, so you'd have, typically for that then, you'll have two different binding elements inside the visual element, each of which identifies, as you can see, a template. Let me use the mouse here. So this is the template string that comes from the catalog. You'll see things like languages and some other base URIs that are used to resolve local references. This little branding thing here is very interesting. That will override whether the text or the badge or nothing shows up on that particular tile update, so you have that capability to switch. And this little thing here called Add Image Query that you see in all these different places, special little feature that we have in this. When you go to issue a tile update, you're going to have typically images in this. Well, the system can be running under multiple scaling factors, multiple pixel densities of 140, 180, and 100%. You can have multiple contrast settings in effect, whether it's a black on white or a white on black contrast setting. And you can have different languages in effect. If you're running a multilingual app that's in different markets, you may be running in Dutch, you may be running in German, you may be running in Japanese or Korean. And you would like typically to let the service that's issuing those images modify the image as appropriate so it comes down with the right language, with the right contrast, and with the right pixel density. So when you set this Add Image Query parameter or attribute in any one of these fields to true, what will happen is anytime Windows sends a request, anytime it sends a request for an image that you reference here in an image source, it will append to that query a query string on the URI that says what language, what pixel density, and what contrast factor is in effect. And then the service can return the appropriate thing there. This is something you do not see in the tile catalog, for example. That's why I'm pointing it out. And otherwise, you wouldn't really know about it. And then you can also see, like up here, you have the language settings. The branding can also be applied at the visual level. You got versioning information and all that. So lots of capabilities there. And TOASTs are similar in that you can also do the Add Image Query business. You have some control over branding, whether or not your little logo shows up. And if you kind of scoot down to the bottom, you'll see that TOASTs also have an audio element that lets you identify one of, I think, 10 or 12 predefined audio sounds. Now, these are just strings that map into your current sound themes. So if you say use the ringing sound, then whatever the user has set as their ringing sound in Control Panel is what will actually play. And that's And you can see you can set it to looping here. You can actually turn it off if you want. I don't really quite know why that's in there myself. But you got various options here. So the reason I wanted to show these full schemas are a little bit hard to piece together from the documentation, but it gives you the full extent of what you can actually do in these tiles and toast notifications and badges. So let me do a quick review of kind of the APIs that we're dealing with here before we go on to looking at implementing the services. I do want to mention secondary tiles because supporting secondary tiles is one of the best ways that your app gets more space on the start screen. Start screen is precious real estate, right? It's a thing where the user can delete and control everything going on there. So if you don't have secondary tiles, you basically get one tile and one tile only. If you have any kind of content that you can think about pinning, then it's actually pretty simple to add that app bar command to pin or unpin if that content's already there, and create a secondary tile, and the user can say whether or not they want to create it. That's a user consent that's built in. And then once the start screen is populated, they can move it around and basically fill that real estate with more of your app. This is a good thing to do, and secondary tiles can have live tiles just like anything else. They can have badges and so forth. And if you launch one of those, there's an identifier with each secondary tile that your activation code picks up and navigates to the appropriate page if it needs to figure out, well, just to figure out where the user intended to go. So you can look at these the samples in the documentation down here that I link at the bottom. Pretty straightforward stuff to do. I was working with Urban Spoon in the last couple of weeks. They went from 0 to an app in the store in 2 weeks. A pretty amazing thing. And then they said, well, we have time to make an update before launch, so let's do secondary tiles. And they did that in a day and a half, really from start, and live tiles at the same time. So it's actually not that much work, but it really pays off well, I think, for the user. So let me go through those 3 ways of issuing updates. So first of all, from the running app, or a background task, some piece of running app code. Use the APIs in windows.ui.notifications to issue these. So you create either a tile or badge or toast notification object, and then you throw that thing, which has a piece of XML in it, to the tile updater, the secondary tile updater, the badge updater, or the toast notifier classes. There's a bunch of classes in there that all just give you the feelers into these different parts of the user experience. So, but basically, in a running app, you create the notification, you issue it, and it shows up somewhere on the screen, either on the start screen or notification appears. Scheduled notifications are very, very useful to keep that sense of aliveness into the future, where the running app will set up the scheduled notification using the APIs listed here at the bottom, where you create a scheduled tile or scheduled toast notification object and then send it off to the updaters again. After you send it off, the app can go suspended. It can be shut down. It doesn't have to be running anymore because that system process is running through the queue of whatever you've scheduled, and when the appropriate time comes, it issues those updates out to the start screen or to a notification. You'll see here it works for tiles and toasts. You don't have scheduled badge notifications. That's one difference there. Periodic updates are kind of a similar thing, that instead of scheduling something in the future, you say, here's a URI that I want the system to make a request to on some interval. At least I think the minimum time is 30 minutes, although as soon as you call the API to start a periodic update, it will go ahead and call that service right away. So you can do this for tiles and badges. There aren't periodic toast notifications. That doesn't quite make sense as a scenario. And you also have this thing called Start Periodic Update Batch, where you can send up to 5 URIs to the system to have it do those as a cycling notification queue. But one way or the other, you can issue these. You can set this periodic service up, let the system run. It will go out and query those URIs as necessary. So let's see how that works, both with kind of in everything running. So what I have here is the push and periodic notifications sample. I'm running the JavaScript one, but the C# one is pretty much equivalent. And I'm going to use scenario 5 first, polling for badge updates. And I have on my local host this little thing here, a dayofmonthservice.php. So it's a very simple web service that basically returns a badge XML with the current day of day of the month. So I start periodic updates over here. If I go to the start screen, you saw that one just appeared right there because I issued that API call. The System in response made a request to it. I generated some XML, I returned it, and that was applied to the tile. So what that looks like, let me go over to Visual Studio Express for Web. If you don't know about this tool and you're going to be working with tiles and updates and services, get this tool. You go get the web installer that Microsoft has, and you'll see it listed there. This tool is what allows you to basically create a website that lets you do the debugging on your localhost service that you have set up if you have internet. Let me go over to that real quick. If you have Internet Information Services here and turn Windows features on and off, that will set up your localhost server on your machine, and then you run Visual Studio Express for Web, and you can basically debug your service at the same time you're debugging the app that uses the service, and we'll see a little bit of that in a moment. But this is the PHP. You can see I'm basically just echoing the XML header and echoing the badge XML with this little piece of executable code that extracts the day of the month from the current date. And that's it. That's all this service has to do. And it will be called periodically to do that update. Now, because this one only updates, it would only change once a day, I can set a periodic recurrence to be something like 24 hours or 12 hours or something like that. Now I got a little more interesting one here. This is a piece of .cs.html. If you're not familiar with this, it's something that has the web matrix or aka Razor syntax that we put out for ASP.NET. I have a breakpoint set on this particular service here, and I don't have it do anything interesting. I have basically a piece of static XML, but I do have a piece of code that I can hit a breakpoint. So structurally we have the entire the structure of the service here, even though it doesn't do much interesting. But let me grab the URL for that, and I'm going to go ahead and use this one, which is tied to a port, my debugging port on my local host, and go over here to this sample and do poll for tile updates. I'm going to paste that in and do start periodic updates, and boom, you see that we hit the breakpoint in Visual Studio for Web. Right on whatever piece of executable code I have, I can step through this like I always do in Visual Studio. I just have one line of code, so I'll step through that, and not much going on there, but let me make sure I've run it. Yeah, continued. And if I go back to the start screen, we will see a gratuitous picture of my son when he was 6 months old. He's now 6 years old. He just turned 6 the other day. But you can see it's here, and it's got the peak update, so we'll see it has this picture, then has this little piece of text, and then here in a few seconds it will go back. So if you look at the XML, you can see that I have a visual with 2 bindings. One for a tile square peak image and text02, that's the name of the update, and it has a URL going out to the web, and then here's the text for that, and then I have the small image here, or the wide image here. So we haven't seen the wide. Let me go change that by right-clicking or tap select and do larger, and you will see that I have a different update being issued. So in that one piece of payload from the periodic service, I have both these particular tile updates showing, and you can see that badge I issued is still there, no problem. Okay, and I also want to show, similarly, just to show it, that these 2 URIs here, I took this website that I created in Visual Studio Express for Web, and I deployed it to a site I created on Windows Azure. So I have this long gobbledygook, azurewebsites.net, and you can see it's coming from Programming Windows 8 and JavaScript Chapter 13. So this is a sample that I have in my book, by the way, the one that we just released on Monday, which is, even though it's written for JavaScript users, half of it's just about WinRT and a chapter like this that covers services. So it's a free ebook, no excuse not to download it, no matter what language you're working in. There's my plug. But anyway, I have this same stuff deployed on Azure, and I can go ahead and put that in here. I'll stop it first to see that, yes, I cleared that out. And then I can start the periodic updates, and we will see fairly soon. There it is, coming from Azure. I'll go back to the smaller tile, and you'll see that the square tile is there as well. Okay. I think I got everything. All right, so let's now talk about push notifications. This is the next interesting part. So similarly to a periodic update, a push notification is a little more complicated because the running app or a background task needs to request what's called a channel URI. A push notification is very personalized, and I want you to think about periodic notifications as something that's a little more general, that you can just have an app get updates like things from a news feed for whatever users happen to be running that app. A push notification is much more personal because that's how you get things like calendar updates and calendar reminders and email notifications and messaging, anything that's specifically tied to that user on that device with that app. That's what a channel URI actually identifies as the user, the app, and the device that they are on. So the running app, when the user fires something up, say they just installed a newsreader app and they want to get their personal updates, they fire that up. The first thing the app is going to do is request channel URI from Windows. It's going to take that URI, send it up to its web service. The web service will store that URI in some way, and basically it's going to need a database of this kind of thing because it's very user-specific. It's going to also then have some authentication tokens. Actually, let me skip to this slide. When you set up an app to use Windows push notifications, you will go to the Windows Store portal, and I think in step 3 there's this link that says Push Notifications and Live Connect Services Info. You go under that, it says Authenticating Your Service, you put in your app name and register it with the store for push notifications, and you'll get back this SID for your app as well as a client secret. These are two pieces that you then have in your web service. Let me go back the other way. Keyboard, and go back here. This is what your web service up there in the right-hand corner will have in itself to use to then authenticate itself with WNS when you're ready to send that push notification. And then when that happens, whatever kind of notification payload you have, which can be tiles, it can be badges, it can be toasts, or it can be what's called a raw notification, which is just some data packet that you send that a running app or a background task can pick up and process independently. So the WNS sends that, and then whatever piece of code can process it on the client machine issues that update locally. So a running app will receive a push notification through this event listed here. Push notification channel, push notification received, or a background task can have this thing, push notification trigger, to know when a raw notification comes in. If you use raw notifications, you really have to implement a lock screen capable app with a push notification trigger, because otherwise Windows will not know what to do with that particular payload and it'll just ignore it. Okay, so let's go over back to my demo machine, because I want to show you how these things are structured and how you can basically do the debugging again on your system using Visual Studio for Web and a running app that you can have running in Visual Studio Express for Windows 8. So you can be stepping through your client code, you can be stepping through your service code, set breakpoints in both, running on your local host, and everything's great. By the way, if you aren't aware of it, I do want to mention that in your project properties under debugging, there is this thing here, Allow Local Network Loopback. This is what enables you to use localhost URIs when you're running in Visual Studio. You can't use it outside the debugger. You can't use it in a running app. It's only allowed inside the debugger. But it's enabled by default, so you don't have to worry about it. But that is where that particular feature is controlled. Okay, so what I have on my website running here on the local host is I have a page called receiveURI.aspx, a piece of ASP.NET code you can see here. And it's basically going to receive the channel URI from the push notifications sample. And let me find where that is here. Actually, I need to go to scenario 1 and pop that up. And somewhere in here, actually, no, it's in this file. Let's see if I can find it real quick. Channel operation. There's a bunch of stuff in here. I don't have it set up. There is an API call. I don't want to go searching for it, but that gets the channel URI, and then basically you send it to the API, or you make a request to your web service, and where that's going to end up is right here in receiveURI.aspx. So I have a breakpoint set there. Let me grab the URL for that in running in the localhost in the debugger. Go back to this app here, the sample that says register a notification channel. So I give it the URI for my service, It's going to open the channel and send it to the server, and boom, we end up in our debugger. So I can examine these variables and see what came through with, I step through these. Here's the channel URI that I got from Windows. Here's the item ID. Here's the user that's been authenticated, and I can basically use that to save this information into whatever database I have. Now I have the world's fanciest database here, which is a text file that stores one item. But basically, if I run that, I have stored it in this channel-data.aspx. Let me pop that up a little bit, and there's basically all this junk that I get that identifies this particular channel URI for push notification. So let's see. So what I'm going to do in this this push notification is issue a badge update. You'll see that the badge on this tile has currently got a 1 on it, and I'm going to switch over to the send badge to WNS.aspx. So I have this page set up so that if I visit it, it will issue that badge update. Now it's kind of a fake situation because typically you will have some other service running. You will have it monitoring information like when emails come in or calendar updates change, and you'll generate a more interesting update from that page without having to have a user actually visit the page and trigger it. But you'll have another trigger of your own kind, but this still shows the mechanism for that. So let me grab that URI and just go to a browser and visit it to trigger that update. I paste that in here, and I hit the breakpoint because I'm on the local server. I got this in the debugger. You can see that I'm going to open my database, channel data._aspx.text, parse everything from there, read the file, make sure I got something, and then you can see I have here my let me go down here. After URI, I have that same URI that I've loaded from my database. Here I have my client secret. I have the identifier. These are the two things, again, that I use to authenticate with WNS. I then build my piece of XML. You'll recognize a badge update here. Very, very simple, just doing an alert badge. And then I'm using this piece of code called post to WNS. This is in the documentation. I took it, I copy and pasted it into my service, and it works great. So I don't need to step through that. It basically just creates an XML HTTP request off to WNS. And it will take a little bit of time to come through. Well, there it came through right away. So right here on this demo, running in 2 debuggers, I sent a notification out to WNS, and it pushed that down to this machine, to this specific machine sitting right here, and gave me a badge update on my tile. So you've now seen the mechanism for writing this stuff, for debugging it, stepping through everything, and I can basically take this service now that I know that it works and upload it to a place like Windows Azure and have it deployed and have it running. But of course, that's a lot of work. And so let me make a plug for Windows Azure Mobile Services, because you have to do things when you're dealing with push notifications of securing your being able to send channel URIs in a secure way to your service, having some way to store all that on a per user, per device, per app basis, so you have some kind of rich database going on there, and have storage for whatever images you're going to have and all the other information that you may be dealing with. So doing all that manually could be a lot of work, and that's what Windows Azure Mobile Services has really been set up to do. And it looks like, yes, later today there is a talk, the Windows 8 Connect-a-thon with Windows Azure Mobile Services. Highly recommend you go to that if you're interested. I also recommend that you go across the way here to the little expo area and talk to the guys at Urban Airship. They're a big name in push notifications if you don't know already, and they're definitely going to be working on stuff for Windows 8 to help you with your apps as well. So definitely go talk to them and see what they have to offer. Switching over to background tasks now. I mentioned before that background tasks, we've seen it a number of times, is how we really get a little piece of app code to run when the main app isn't running. And let me skip down to the very bottom line on this slide. And point out something I pointed out in my talk yesterday, if you were there, that background tasks do not need to be written in the same language as the rest of the app, because they basically run independently. So if you have a JavaScript app, you can write a background task in C++. I think you can actually even write a JavaScript web worker background task in a C# app. I haven't tried it, but I think it might actually work. But the point there is that you can really use the right language for the job for background tasks that has nothing to do with the rest of your app. Because what a background task gets to do is either issue toast or tile updates or badge updates, or it can write information to your app data and change your app state. That's pretty much what background tasks do, but there's a lot you can do with that. So the kind of things you want to care about where notifications are concerned is as follows. So there's a kind of trigger called a maintenance trigger that you can basically set up to run on some interval anywhere, I think, from a half hour onward. One of the really key uses for this with push notifications is to periodically make sure that you are renewing your channel URIs. Each channel URI has a 30-day lifetime. So if your app has not been run for 30 days, those push notifications that you want set up will stop happening. And so it's a nice idea, and one of the samples will shows how to do this to set up, and I'll show it on a slide here in a minute, basically how to use a maintenance trigger to run like every 10 days to go out and renew your channel URIs and make sure those are always going to be set up. There are some other system triggers you can use, things like checking whether there's connectivity, checking whether your app's been updated, checking whether your app has been added or removed from the lock screen if you want to make some modifications there for how you're dealing with raw notifications. And then more importantly for things like updates is the ones that you get if you're on the lock screen. Specifically the push notification trigger, again to receive raw notifications. You can also do things like time triggers, which an alarm app would use. Control channel triggers, which gives you socket things for real-time communications apps. Very important to be able to run that kind of thing when you're on the lock screen. Apps may not be running, but your background test for RTC can keep VoIP things going, can keep messaging going, and so forth. Okay, go here. So let's look at a little bit of this code. So Windows Application Model.background is the namespace you're going to find all this stuff in. There's a thing called Background Task Builder. This is what basically lets you set up a background task and register it with Windows. This is an example from I think it's from the raw notifications sample. I think this is the C# version of it. Where we're creating a maintenance trigger that's got a period of 10 days. And we set the entry point, which is a thing in a C# module. We set the name of that, and then down here at the bottom you see taskbuilder.register with an added condition to say only run this if the internet's available. So if the internet's not available, don't bother to run it, because I can't renew channel URIs if the internet's not available. So wait until that's done, or wait until that's ready. And in fact, if the 10 days passes, the internet's not available, when it does become available, Windows will remember that and fire this background task. Here's what that task would look like using a notifier helper library that's actually in the SDK samples as well. A background task, as I mentioned yesterday, if you were there, is basically a class that derives from iBackgroundTask, has one method called run, and whatever you stick inside that run method is what gets executed. Simple as that. So here it creates this notifier object from this little piece of sample code and goes through and renews all the channel URIs, and that's how it works. And that's just really the same process as before, requesting a URI, sending it to the service, and the service will then need to make sure that it's replacing an older URI that may have expired. That's one of the jobs it needs to do as well. Again, Mobile Azure Mobile Services can help there. On the JavaScript side, here's pretty much the same kind of thing. This is the same background task written in JavaScript. It runs as a web worker. And so you'll see that we have basically pull in the scripts. This notifications.js is the thing that has the renew all async function in it. I do want to mention with background tasks in JavaScript, you will often in the sample see this close call. It is not window close. This is worker.close. Because you're running this in a worker context, not a window context. And you should never call window close in an app. That's actually forbidden by store certification. But you can call worker close, and you, in fact, need to do that for your background tasks. Here's what a background task, how you register one to handle receiving a raw notification. Again, just use the builder, use the right trigger, which is push notification trigger, set the entry point, set the name, and call register, and you will be set up to receive that. The task that would receive that particular, this comes out of the raw notification sample. You can basically see again we have a class derived from iBackgroundTask, has a run method on it, And what it basically does is extract here the notification content and saves it to the app data local settings. So it's received the raw notifications, it's written it to app data, and then when the app runs again, the main app runs again, it can go pick that up and process it as it wants to. So let me just give you this slide as a summary that to really help you see the different kinds of notifications that are available, the different features that are available for those notifications. So the cycling or up to 5 queuing, rotating notifications only applies to tiles. Scheduled notifications applies to tiles and toasts. You can have expiring tiles, badges, and toast. Recurring toast, you can have a recurring toast that keeps showing up so that if it fades away after a certain amount of time, it will show up again in a couple minutes. You use this for calendar reminders like you're probably used to. And those can also have audio. You can have periodic tile and badge updates. And then push notifications, basically, you can use across the board and use raw notifications as well. That's the one case where raw notifications only works there. You don't have periodic raw notifications, for example. And then also to wrap up, just a few kind of pointers, guidance on kind of when should you update these things, what kinds of updates you need to use. So if you want anything that's really personalized or tailored to the user, that's going to be push notifications. You can, in fact, if you think about periodic updates, where you're just giving a URI to a service, you can put query parameters on the URI that will do a little bit of customization for the user, because each app is going to be making that call on each device. It can tag on some personalization stuff there, and then if the service wants to change what it's returning in response to that request, it can do so. So you can do some personalization with periodic updates. That's fine. But if you're really going to be sending exact information to the users, that device, that user, that app, then push notifications is really what you want to be dealing with here. Now, you can read the rest, and some things of where to not use these notifications are special things. So don't think that tile updates or toast notifications are for like high frequency streaming updates or things where you're like trying to create a 1 second update clock on the start screen. It's not meant for that. It's not going to work. If you do anything annoying to the user, like a tile that's just too noisy or too chaotic, or you do too many notifications, remember that in PC settings the user can go turn all of that off. So don't defeat your own work by giving the user an excuse to just shut all this off. Give them something that's valuable. Give them something they want to have on that adds value to their start screen, adds value to notifications. You want to make sure there's an API call to clear badge updates and tile updates and so forth. Make sure if you're going to replace a tile update, you usually clear it and then send the new one. You don't want to clear these if you're shutting the app down or the app is closing, because the whole point is to keep that activity going while the app isn't running. Do not update to explicitly replace old content. Use the expiration time instead. You can, in fact, if you have current content that's not expired, like with cycling tile updates, each one of those can have an individual tag, and you can replace each tile update by the tag if you want to. So if you have like 5 different news categories and you're showing the latest feed from each one of those, you can replace one of those categories at will if you want to. And you also need to know that cycling tile updates like that have no inherent ordering. You can't control that, so don't depend on it. With that, again, later on this afternoon, there's a great session going on with Azure Mobile Services. And there are plenty of pieces of documentation and guidance and samples. I've just kind of run through the gamut here. I got links in the slides, but you can basically just search on these titles and you'll find it on the Dev Center as well. So you can basically get all the different pieces of code, all the different pieces of examples that you want to do everything we've talked about here. With the exception of the sample services, you got to go to my book here, Programming Windows 8 Apps in HTML, CSS, and JavaScript for that. I wrote all those because when I started working with the samples, I say, well, that's great. I got this sample that I can stick a URI into, but what URI? I asked the Windows team that created the samples, like, do you have a sample service? And I said, no. Okay, I guess I got to create one. So my work is your benefit. Go out there, grab the book again. It's free, so no problems there. And be sure to fill out your session evals. Obligatory slide. You've seen this probably a dozen times already. And with that, I believe we do have 10 minutes or so for questions, so I'd be happy to answer any that you have. Thank you.
Is there a limit to the amount of push notifications you can send through DNS?
Is there a limit to the amount of push notifications you can send through WNS? There is at some point. I don't know the exact number offhand. Yeah, I don't remember that one.
Have you ever reached that limit? Is there a paid version?
I don't think there is, but I don't know offhand. Good question, though. So was there another one right up here? Oh, there's lights. Okay, here in the front.
With raw notifications, if your app is not running, do they just get locked, or do you get woken up in the background task and push through?
Okay, so your question is what happens to a raw notification if your app isn't running? So if your app is running, you get that event, push notification received. If it's not running and you don't have a background task, I think it just disappears. If you have a background task, then it will be fired up in response to that notification. That's what that push notification trigger is for, is to receive raw notifications. But you do need to be on, the user has to have added your app to the lock screen.
So you have to be a lock screen app.
You have to be a lock screen app for that, yes. Okay, others? Yeah, way up here.
How much of these are common to Windows Phone 8?
Sorry, say that again.
What are the similar things to Windows Phone 8 notifications?
Yeah, there's a lot of similarity and overlap here. I don't know the details of that myself, but definitely there's the push notification that works there. But yeah, I don't have the details on my head. So, any over here? Yeah, in the front.
So my understanding is push notifications are unreliable. We don't really know if there's any receipt of them through Windows Notification Service. Is there a pattern that helps us see if there is a receipt?
Is there a pattern to see if we actually know if the push notification's been received or not? As far as I know, the best you get is when you send it to WNS, if it responds back with in its response, it gives you an error code, an HTTP error code of some kind, then you'll know that there's something going on. If it responds with a success, then you know that it's been received, and it will keep trying to send it down. I don't know how long it keeps trying, but if that machine isn't connected or it's not on, it'll queue those up, and then it'll try to send it down when it does get connected.
But there's no way to query a status from WNS.
That's right. There's not a query status for that, at least at this point. That's a good option that we could maybe have at some point. Yeah, up here.
You scheduled a maintenance task for so many days. Is it possible to schedule it for like every hour or something?
Yeah, maintenance task has a minimum resolution of, I think, 30 minutes or 15 minutes, something like that. So you can do it on an hourly basis, and you'll basically run, if you're on AC power, it will run, and you get it, like, I think the slide said 2 seconds of CPU time every 15 minutes. That's basically and you can do a lot in 2 seconds of CPU time.
Correct.
Yeah.
That's if you're on the lock screen.
No, for maintenance tasks, no, that's just AC power.
Oh, okay.
That's not a lock screen one. So does that answer your question?
Yeah, so the battery you cannot run it, like it has to be on AC power and it will periodically run it.
That's right. Maintenance tasks don't run on battery. Yeah. So if you're on your Surface and somehow you've never plugged it in for 30 days, then your channel URIs might expire. But if we get that kind of battery life, or like a nuclear battery or something, it might actually work. But be a good problem to have. Yes, right here.
I have had issues with push notifications while registering the channel on the simulator when you test on the simulator. So is that something known issue? Because
Yeah. So the question is about testing on the simulator. Tile updates, toast notifications, and raw notifications don't work in the simulator. I should have mentioned that before. You need to run it on the local machine or the remote machine. Because, you'll also see that things like tile updates and animations don't happen in the simulator either. So, yeah, the simulator's nice, but it does have that limitation that notifications don't really work. So, yeah, thanks for pointing that out. I forgot to mention it. Anything else? Yeah, way up there.
You're not planning to register on the Windows Store.
So say that again. If you're not planning to register with the Windows Store.
You still get the push notification.
Yeah, and that's right. So what I showed you before, I did for a sample. I did for the push notification sample, and you don't have to have the app actually go through store certification. That's just something you ask the store dashboard for anytime. So if you're just experimenting or you're going to do an LOB app or something like that, you can still get that. That goes back to the WNS backend, gives you that information, and it's valid from that point. Yeah, here.
You mentioned on one of the previous sessions that you held that background task can be used to clean up temporary files.
Yes.
Is this falls under the same only when you're on the AC power, or can it be done when you on the battery power too? Because if temporary files keep accumulating, it might up. If that's the only way how I design the program.
Yeah. So the question is for the maintenance triggers basically running on AC power only. And in my talk yesterday, I mentioned that's a good time to clean up temporary state. You really should only do that for a maintenance trigger. And if you think about it again, what's the battery life of a typical device? It's going to be plugged in at some point. Right? It's not going to just run for a month without ever being plugged in. And so it's kind of one of those things where we had to make the decision of what actually gets to run on AC power, what gets to run on the battery. And we're really trying to preserve the scenario where the user is out and about with the device. Probably not at the right time to be cleaning up temporary files. So I think you'll have to see how it works for you. If you're creating just tons and tons, but you only have so much you can do on AC power. But a maintenance trigger, you can really do anything you want in a background task. So if you want to try to clean something up when you're receiving a push notification, you can do that. And it'll work on battery power when you're on the lock screen. But it just may not be the right use of the limited resources that you have.
File contains sensitive data, and it is really desirable not to keep it on the device for a long time if it's not sensitive.
Yeah, so if it has sensitive data, I might want to delete it right away. Well, you may want to do that cleanup in the app itself. You could definitely do that cleanup when you received a notification or some other lock screen related trigger. And you also want to make sure you definitely are encrypting that. Don't just store raw sensitive information, in text or something. So there's encryption APIs you can use to make sure that's not just readable by somebody casually browsing the hard drive. Okay? Okay, one more? Yeah.
Behind the scenes, if, say, a mobile device wants to know whether it needs to show a notification, change the dial, or kind of that sort, you said you're relying on Windows mechanisms for receiving these notifications. Just maybe a little insight. What do you do behind the scenes? Do you do like long pooling so the mobile device is always connected to the backend, or do you do periodic queries and see, do I have something, do I have something?
Yeah, I don't know the answer to that. I wish I did. Anyway, we are out of time, so if you have any more questions, I'm happy to meet you up here. And otherwise, thank you for your attention and enjoy the rest of the conference.